Today I'm going to do a video on what is a function. I had a couple students ask me what a function is, and I thought I would do a 5-minute video explaining the definition of a function. So let's first write down the definition. Definition. A function is a relationship between two variables in which each input, the x value, has only one output, the y value usually. So for the most simple example, I'm going to ask, is y equal 2x, which is a relationship between variables, one variable twice another, is that a function? If you make a table for y equals 2x, you will notice that no matter what I plug in for x, which is the input, there's only going to be one value for y. So if I plug in x as 1, I double it, I get 2. If I plug in x as 2, I double it, I get 4. And same with 3, doubling that would be 6. For each input, there's only one output. So is y a function of x? In the first example, yes. We're going to see other relationships in the future. Here's an example, another example, x equals y squared. I know we haven't graphed this yet, but we could always make a table. So let me go ahead and do that. And I notice if I input 4 on my table, what am I going to get is 2 answers for y. One is 2 because 2 squared is 4, but the other is negative 2 because negative 2 squared is 4. So for each input, 4, there were 2 outputs. So y is not a function of x. This is a no. But you have to be careful, because what if you had this example? Let's make a table. So if I do my example 2, try to plug in 2, you notice I will get 4. But there's only one answer. I do realize that if you plug in negative 2 for the same reasoning here on the left, we are going to have also 4. But for each input, there's still only one output. So the answer is yes. Y is a function of x. The reason I say y is a function of x up here on top is because if I asked if x is a function of y, then x would be the output and y would be the input and everything would be all turned around. But usually they only ask if y is a function of x. So that is 3 simple examples. If we look at the graphs of these 3 examples, this one turns out to be something like this one. X is 1, y is 2. This example here, I should add the point 0, 0 here because that is another point to make it easier to graph. And plot these 3 points, 0, 0, 4, 2, and 4, negative 2. The graph you're going to graph these in another chapter. But just to let you know, the graph looks something like that. And on the last one, if I add another point here to just get another point 0, 0, what that graph looks like is plotting 0, 0, and then I'm going to plot 2, 4, and negative 2, 4. We're going to graph these again in another chapter. That gives you an idea of what that graph looks like. The book talks about the vertical line test. And what happens in a graph, when you're looking at a graph, if for each input there's only one output, if you draw a vertical line, it will only hit the graph once. Where here, the middle one, which is not a function, if you graph a vertical line, or draw a vertical line here, imaginary vertical line, so let's do it in a different color, you'll see for each input, there is 2 outputs. Here, no matter where I draw that vertical line, only one answer. So in this one, when we draw the vertical line, you see that there is for each input only one output. Whoops, my lines are weird. Maybe I could do it even a different color, red. And you can see where the red line, there is only one output. So let's write down, go to the next page, that definition. So a graph represents a function if and only if every vertical line intersects the graph in at most 1 point. Applications. Let's look at this example. Say X represents the price of an item and Y represents the tax of the item at 8%, or on the item. And again, the question is, why a function of x? Well, here the answer is yes, because for each price, say $4, you multiply that by 8%, your sales tax will be unique. There'll only be one answer. On the other hand, if you look at the example where the input, the x is the distance flown on an airplane, and the y is the price of a ticket, that will not be a function, because if there's different prices for each person on in the plane. For instance, standard seats might cost less, or will cost less, than first class seats, and they're going the same distance. So we have one distance, one input, and they have two different prices of the ticket. So the answer for this is no, not a function, and the answer for this is yes. The first one, it is a function. Last examples. And the last thing I want to talk about is the notation. So when things are a function, when relationships are functions, they have a new notation for writing it. So if y is a function for x, we write y equals f of x. F is not multiplied by x. It's just letting you know, hey, this is a function, and x is the input, and y is the output. So the example I'm going to choose here is that last one that we looked at. That was a function. This was a function. So now we are going to write, this is the old way of writing it. This, if we now know it's a function, we can write f of x equals x squared. So you might see something that looks like this. If that ever bugs you, you can always change f of x for y, and it would be in the old notation. Why do they do this? Well, it allows you to input or write the inputs in a new way. So if you remember from our table, let's go back up and look at that again. So this is the one I'm taking. If you remember, 2, 4 was a point on the line. So in a table we wrote 2, 4. So before we wrote, when x equals 2, we would have y equals 4, or we would have wrote it in an ordered pair or a table. But now, what can we write? We can write f of 2. What is f of 2? That's the input. You plug in 2 squared is 4. So basically, you can now just plug in whatever number one you have, like for instance f of 1 or 3. Let's do f of 3. F of 3 would be 3 squared. You just plug it right in there, which is 9. That is the new notation. I hope this helps. Good luck. See you next time.